Greetings everyone. In this lecture, we are going to see the most important topics of quantum mechanics in the field of physical science. We all will be familiar with the definition of quantum mechanics, but what actually quantum mechanics is? Quantum means discrete or minimum amount of any physical entity, and the mechanics means motion. Please make a note of the definition of quantum mechanics, which is in the lower part of the slide. Being a quantum physicist, we all familiar with the word wave function. What actually wave function means? Let us consider electrons as our example. We are going to pass electrons through the slit. The electrons moves through the slit and it reaches the screen. For that purpose, we cannot take an electron like a ball and throw it. Assume that we are having an electron gun on the left hand side of the screen, through which beam of electrons is generated and passes through the slit and it reaches the screen. Don't consider the diffraction pattern which is in between the slit and the screen. Just do notice the screen which is at the right hand side of the slide. The green color represents the arrival of electrons. We can able to observe green colored bright, dark, band-like appearance on the screen. We can see the wave diagram which is drawn with respect to the patterns which is observed on the screen. From this visualization, we can able to confirm that the electrons will create a wave-like pattern. Through this representation, we can able to show that the position of electrons will be anywhere in the wave representation. So ultimately, we can say that electron is a wave. It will be anywhere in the wave representation. Do remember the concept of wave-particle duality. Assume we are going to throw a ball. Why the ball is visible to our eye? The only reason is the ball is moving at the velocity which is lesser than the velocity of light. But this phenomenon won't be applicable for the particles like photons and electrons. Assume photon instead of ball. As an evident, we all know that photons moves at velocity which is relative to the velocity of light. From this explanation, we can able to confirm that it behaves as a wave. Let us see how it behaves as a particle. This picture is taken from one of our previous slides. As we have already discussed, electrons passes through slit and it reaches the screen. The position of the electrons will be anywhere in this wave pattern. This shows that psi wave function is nothing but the position of electron in the wave pattern. Square of the wave function represents the probability density, which gives the information about the distance of electron from the nucleus of an atom. Overlapping or mixing of two waves are known as interference. Interference are divided into two types. One is constructive interference and another one is destructive interference. Crest plus crest or trough plus trough gives constructive interference, which means crests of two waves overlaps, then it is known as constructive interference. When crest of a wave and trough of another wave interferes, then it is known as destructive interference. Wave formation in water also a good example for this case. Schrodinger's equation, probability of finding particle at a certain position, which means we have already discussed that in the wave function the electrons will be located at anywhere in the wave. This equation is used to finding the position of the electron or a particle. Heisenberg's uncertainty principle states that it is impossible to measure the position and momentum of a particle with absolute precision, which literally means we cannot able to measure the position and momentum at the same time. If we measure the momentum, we cannot able to measure the position. If we measure the position, we cannot able to measure the momentum at a single instant of time. Let us confirm the statement by doing some experiment. Assume we are going to pass a laser light through a slit. We are going to observe the response of laser light on minimizing the width of the slit. Initially, the slit is fully opened. After that, we start to minimize the width of the slit. Now, appearance of laser light on the screen starts to reducing. In general, as we minimize the width of the slit, the appearance of the laser light on the screen have to be minimized and it vanishes. But here, something happening different. As minimizing the width of the slit, initially it reduces its spot. After some time, it starts to expand. This is happening because the photon acts as a particle. When the width of the slit reaches the value h, The photon particles struggles to move through such a fine path and it starts to diverge. This condition confirms that photons acts as a particle. Thanks for watching this lecture. Please do like and subscribe.